Hi, I'm Yuri from CodeVibers. In this project, we handle AI automation in-house, develop AI tools for businesses, and run an educational academy. This channel is for those who want to use AI in products and processes, without the illusion that a single successful prompt has replaced development altogether. Today, we're breaking down where Vibecoding breaks down, not because it's bad, but because there comes a point where rapid back and forth with the model stops saving time and instead produces a product that's unpredictable to review, test, and maintain. By the end of this episode, you'll have a simple rule: knowing when to keep building yourself, when to write a specification, and when to hand the task over to engineering development. If this breakdown is helpful, subscribe to the CodeVibers channel, like the video, and hit the subscribe button. First, to be honest, Vibecoding is genuinely useful. It's great for quickly prototyping an interface, sketching out ideas, testing concepts, or building internal utilities. The key condition is that mistakes are quickly visible, nearly cost-free, and can be rolled back without impacting customers or data.
So we'll go from the prompt editing over to the AI still continuing to code. And we'll go back and forth until we reach that desired implementation after a few tries, right? So we are at the desired state of implementation.
Remember 5 stop signals. First, the feature has defined user roles. Second, it modifies data, not just displays a screen. Third, it involves money, personal data, or access credentials. Fourth, it calls external services. Fifth, its output must be reproducible tomorrow exactly as it is today. If at least 2 signals are present, free-form Vibecoding should be replaced by a specification.
So let's take a look at what spec coding looks like in a hypothetical scenario. So spec coding or spec-driven development, again, is going to take into consideration some of those software development lifecycle aspects, right? But also use the LLM just like Vibecoding in order to...
The minimum specification shouldn't be a massive document, just 1 page for the first version. It should cover what the feature does, who the user is, what input data it accepts, what constraints must not be violated, what errors can occur, how to handle errors, and 5 acceptance tests. If you can't write this down, you don't yet know exactly what you're building.
Then what variables are we going to take for the username and password? Well, we can say, hey, we're going to accept 2 different variables. So they're going to be user and then pass. Awesome. So that is in there, and we know when the implementation starts why it got...
Now, the practical solution: keep coding if the task is one-time, reversible, and verifiable by eye. Move to specification if roles, states, errors, or repeatability emerge. Hand off to engineering development if the feature involves money, personal data, access rights, integrations, or client commitments. This isn't about a developer's seniority, it's about the cost of a mistake. 2 examples. First, the founder builds a landing page to validate an offer. You can vibe code it. You might lose an evening, but you'll quickly iterate and fix it. Second, the same founder builds a personal dashboard with payment integration, role-based access, and client document management. Here you need a spec, tests, code reviews, and a clear rollback plan. Visually, it might look like the same screen, but the risk is entirely different. Take one feature you're currently building with AI and run it through the 5 signals: roles, data changes, money or access, integrations, and repeatability. If 2 or more signals apply, pause and write a 1-page specification. More practical breakdowns like this will be available in the CodeVibers Academy. Subscribe to the channel, like the video, and hit the subscribe button.